Let's continue talking about binomial random variables. In the scenarios we're about to look at, we're going to be seeing keywords like at least, less than, or more than. So in this example, we're examining that there's a 6% chance that if you order a package from Amazon, it will not be delivered on time. So 20 randomly selected past orders are being examined. What is the probability that no more than 3 of them were not delivered on time? So what does this mean? No more than 3. So that means 4, 5, 6, 7, all the way up to 20. So we're looking at the probability that X, our random variable, our Amazon orders not being delivered on time, is less than or equal to 3 out of these 20. Now this is binary. It's either delivered on time or it's not. We can assume independence here because there's a random selection of the package. Also, that 20 is less than 10% of the entire population of all Amazon packages. So there is independence here. We have a set number of trials, which is 20. That's our N. Our success rate is not going to change. I know it seems a little bit weird to say success rate meaning the package is not delivered on time, but that's the probability we're examining, that the probability is the package is not going to be delivered is 0.06, which means the complement to that, 1 minus P, is going to be 0.94. And we're examining there are 0 not delivered on time, 1, 2, or 3 not delivered on time based on this problem. Well, using the skill sets we have so far, we could calculate the probability of X equaling exactly 0, and then add that to the probability that X equals exactly 1 package not delivered on time, plus the probability that X equals 2 packages out of the 20 not delivered on time, plus the probability that X equals 3 packages not delivered on time. And then I would have to use my binomial formula 1, 2, 3, 4 different times. So I'd have to look at out of our 20, there were 0 packages not delivered out on time. So that'd be, and this formula is on our formula sheet. We also know how to find this in our calculator. But as you can see, this would take a lot of times. I'd have to do this same formula 4 different times. So what can we do? Well, thankfully, our calculators are so smart that they can calculate this for us. I'm not going to finish that. So our calculators can examine this probability that X is less than or equal to 3. But it's very important that it is set up this certain way where you have this less than or equals to sign. Otherwise, your calculator's not going to be able to calculate this answer correctly. Okay, so you need to see that sign if you're going to use your calculator. So now we're going to go to our calculators. Okay. We're going to go back into second vars, distributions, and if you scroll, we've scrolled down to binomial PDF, we're going to go to binomial CDF. This is cumulative. We've got 20 trials, our probability of success is 0.06, and we're going up to 3 successes. Remember, a success in this scenario is that the package is not delivered at time. There were no more than 3 packages not delivered on time. And so now what this calculator is going to do is add up all of these values for us. And of course, my calculator just died. No, it's not going to do that. Okay. Well, now you know how to get that in your calculator. You can go ahead and try and find that final answer here. Let's look at how we would set up this second scenario. 6 randomly selected orders are examined. So now N is just 6. What is the probability that less than half were not delivered on time? So the probability that X is less than half of 6. Less than half of 6 is the probability that X is less than 3. So now remember what I told you. If I'm going to use my calculator here, I have to have this not as a less than sign, but a less than or equal to sign. So I need to think, how can I rewrite this same probability statement, but using a less than or equal to sign? Well, since this is discrete, being less than 3 is the same as x being less than or equal to 2. Meaning I either have 0 packages that are not on time, 1 package that is not on time, or I have 2 packages not on time. All those values are less than 3 packages not being on time. So you can go to your binomial CDF, cumulative. We have to add up all these likelihoods. You have 6 trials. The probability of success is still 0.06. The probability that it's late is 0.06. And we're looking at up to 2. So make sure you put a 2 there. Notice I did not put a 3 in this scenario. And that should get you 0.996.